The year has barely started, and AI robots are already crossing lines that used to feel years away. This month, IO Technology revealed something wild: a realistic humanoid robot you can actually buy for $7,999. Figure showed what real human-level movement looks like, with a live demo of Figure 03 running smoothly on its own. Tesla raised the stakes by showing Optimus learning precise, controlled tasks that point toward real-world jobs, not just demos. And a Unitree G1 robot hit a man in the lab, drawing global attention. Hey guys, Alfie here. Welcome back to AI Nexus. Eva.i, developed by IO Technology. Eva.i is described as a bionic embodied AI companion. That phrase sounds complex, but the idea is simple. Eva.i is designed to feel present, not just responsive, but physically and emotionally aware. This is not a toy, and it is not a screen-based assistant. Eva.i is a physical AI companion built to interact using sight, sound, and touch at the same time. The team behind Eva.i is not experimenting casually. The emotional AI system is led by a technical director with a PhD from the University of Washington. The robot's face and body were designed by a former Marvel Studios artist with 18 years of experience creating realistic characters. The motion system was refined by engineers from Tsinghua University. Research support also came from the Chinese Academy of Sciences in Shenzhen. This is a carefully engineered product, not a prototype rushed to market. Eva.i is also the foundation of a much larger vision. IO Technology is building an ecosystem called Robonova World. This ecosystem includes multiple humanoid robots, each built on the same hardware platform, but trained with different personalities. Most of these robots cost $10,500. Eva.i stands apart as the entry model, priced at around $7,000. With only 200 units planned for the initial Kickstarter release. To understand why Eva.i feels so different, it helps to look at how the body is built. Eva.i uses a 3-layer composite skin system. The first layer is a thermal system that keeps the surface temperature at 99 degrees Fahrenheit or 37 degrees Celsius. That is the same temperature as a human body. When someone touches Eva.i, the surface feels warm instead of cold or artificial. The second layer is an electronic skin made using flexible circuits. This layer detects pressure and temperature changes. A light touch, a firm press, or a sustained contact all register differently. The system sends that information directly to the AI brain. The third layer is a precision outer shell designed to look and move like real skin. Beneath all of this is an aluminum alloy frame with intelligent joint control. This allows Eva.i to shift posture naturally, display subtle facial movements, and even simulate breathing. The chest rises and falls in a calm, rhythmic pattern, reinforcing the sense of presence. Eva.i does not only react visually. The robot sees, hears, and feels at the same time. This is called multimodal interaction. Instead of processing voice, vision, and touch separately, the AI combines them into one understanding of the situation. We break down AI and humanoid robots based on facts, not speculation. Subscribe if you want to understand where this technology is really going. There is also a clever design choice that avoids a major problem in humanoid robotics: the uncanny valley. Instead of placing cameras inside the eyes, Eva.i hides its vision system inside accessories like glasses or decorative elements. This allows the eyes to remain clear, expressive, and lifelike. The robot can still track faces and expressions, but without the unsettling dead eye effect common in other humanoids. The AI system analyzes voice tone to detect emotional states such as calm, stress, excitement, or hesitation. Facial cues help confirm mood. Touch input adds context. All of this happens locally on the device. Eva.i can operate fully offline, using onboard processing and encrypted storage. Cloud features are optional and controlled entirely by the user. The companion app plays a key role in this experience. The app connects the physical robot with a virtual interface, creating what IO Technology calls a fourth relationship. This is not family, friendship, or romance. It is described as a relaxed emotional connection without pressure or fear of rejection. Do you think a fourth relationship is healthy or risky? Comment your thoughts. The app tracks emotional patterns over time. It learns which topics feel engaging, which conversations bring comfort, and which interactions help stabilize mood. Psychologists were involved in designing these systems to support emotional independence rather than dependency. The company is clear that Eva.i is meant to supplement human interaction, not replace it. Eva.i is only the beginning. The Robonova lineup includes several other humanoid companions, each priced at $10,500 and built around a specific role. Akira is designed as an heiress and entrepreneur personality. Conversations focus on business ideas, planning, and decision-making. The AI adjusts tone based on confidence and hesitation detected in speech and facial expression. Aria is a fashion-focused storyteller. The AI discusses style, trends, and creative expression. The vision system can observe clothing choices and guide conversations around confidence and presentation. Marco is trained as a restaurant owner. Topics include food, hospitality, and service culture. The robot responds naturally to gestures like handshakes, supported by pressure-sensitive skin. Mirinda is built around dance and movement. Enhanced joint control allows smoother motion. The robot can mirror movements and adjust breathing rhythm to match music tempo. Riku represents an art school student personality. Conversations center on visual art, creativity, and design thinking. The AI adapts encouragement or critique based on emotional signals. Sook functions as a product manager companion. Discussions include technology, planning, and teamwork. The AI detects frustration or confusion and adjusts explanation depth accordingly. All of these robots share the same core technology: warm surface temperature, electronic skin, hidden vision systems, offline emotional AI. The difference lies in personality training and interaction focus. If you could choose just one personality, which one would you pick? Comment the name below. I'm curious. Eva.i shows AI moving from screens into a physical body. Now let's switch to AI trying to become the brain of the internet. xAI's Grok-5, and why the AGI race just got real. Everyone keeps saying AI is getting smarter every day, but most people don't realize how close we actually are to AGI, Artificial General Intelligence. While everyone is impressed by Grok 4.1 and busy comparing it to Gemini 3, something much bigger is being built in the background. Elon Musk has already said that Grok-5 has a real chance of being the first system to reach AGI. I've been tracking xAI closely for months now, and what I found about Grok-5 genuinely surprised me. This model isn't being designed as just another chatbot. Grok-5 is being built to become the smartest digital entity on the planet. And to understand the scale of this, consider this. The US Department of Defense has launched a new AI platform, and Grok is set to be one of the core models powering it. What's coming with Grok-5 isn't just faster AI, it's a system designed to understand the world in real time. Let's dive in. So let's start with the big question. When is this thing coming? For a while, we thought we'd see Grok-5 in late 2025. But that didn't happen, and there is a specific reason for that. Elon Musk confirmed that they delayed the training to make it bigger, much bigger. According to the latest reports and Musk's own statements, Grok-5 is now targeting a release in the first quarter of 2026. That means between January and March, the world is going to change. But here's the crazy part. Musk isn't just promising a better chatbot that can write better emails. In a recent interview, Musk said that Grok-5 is really going to feel sentient. He even put a number on it. He said his estimate for Grok-5 achieving AGI, that's Artificial General Intelligence, or AI, that is as smart as a human at everything, is about 10%. Now 10% might sound low to you, but in the world of science, a 10% chance of creating a digital mind that rivals a human brain is absolutely terrifying odds. It's non-zero, and he says that probability is rising. And yes, I know how that sounds. Every year there's a new AGI is coming headline. But this time, the people building it aren't talking casually, and the systems behind it aren't small experiments anymore. You might have missed this news because it sounds like sci-fi, but it's very real. The US Department of Defense has launched a new AI platform called GenAI MIL, and one of the main systems powering it is Grok. Yes, the same AI that started as a bold, internet-facing chatbot is now approved for military use. Grok has been cleared to operate at Impact Level 5, which means it can handle controlled but sensitive government information and support mission-critical tasks. That's a big deal. It marks a clear shift from Grok being a consumer tool to becoming a national-level system trusted by the military. When an AI is approved to help give soldiers and strategists an information advantage, it's no longer just a tech experiment. It's part of real-world defense operations. Pause for a second and think about that. An AI that started as an online chatbot is now being trusted for military decision support. If that doesn't change how you look at AI, I don't know what will. Building an AI brain this powerful is incredibly expensive, and Grok-5 proves that. To make it happen, XAI raised a massive $20 billion in a Series E funding round in January 2026, pushing the company's value past $230 billion. That's more money than the entire economy of some countries. This money is going into heavy infrastructure, massive computing power, advanced hardware, and the electricity needed to run systems at an extreme scale. This level of investment shows that Grok-5 isn't being built as a product for fun. It's being built as the foundation for something far bigger and far more powerful. You can't run Grok-5 on a normal server. It requires a massive industrial-scale system built to handle extreme computing power. Enter Colossus. Built by XAI in Memphis, this is the massive supercomputer cluster created to train Grok-5. Normally, data centers take years to build, but the first phase was completed in just 122 days, earning it the nickname the Gigafactory of Compute. It began with 100,000 NVIDIA H100 GPUs and later doubled to 200,000 chips. XAI has since added a new nearby facility, jokingly named Macro Hardar, as a playful jab at Microsoft. When fully built, Colossus is expected to use up to 2 gigawatts of power, enough to run a city. This isn't just a data center, it's industrial-scale intelligence built for one purpose: training Grok-5. So what actually makes Grok-5 special compared to ChatGPT? First is the scale. Grok-5 is confirmed to be a 6 trillion parameter model, which is about 3.5 times larger than GPT-4, estimated at around 1.7 trillion parameters. Parameters are like brain connections. The more you have, the smarter and more detailed the thinking can be. But according to Elon Musk, size isn't the real advantage. The focus is on intelligence density, meaning the data is carefully selected instead of dumping the entire internet full of noise. Grok-5 also uses a system called Mixture of Experts, where only the right parts of the AI wake up for each task, making it fast and efficient even at massive scale. That combination of size, cleaner data, and smarter design is what sets Grok-5 apart. If you believe Grok-5 could be a real step toward AGI, hit subscribe. We'll be following this before most people even realize what's happening. Here's the feature that truly sets Grok-5 apart. Unlike most AI systems, which are mainly text-based, Grok-5 is natively multimodal, meaning it was trained from the start on text, images, audio, and video. According to Elon Musk, an AI that can't understand real-time video can't understand the real world. And without that, true AGI isn't possible. Grok-5 includes a reality engine that can watch live video, like drone feeds or Tesla cameras, and understand what's happening instantly, including basic physics and motion. This real-world understanding comes from Tesla's massive fleet of cars, collecting video data every day, something no other AI company has. On top of that, Grok-5 has a truth mode powered by its connection to X, giving it access to real-time events and self-fact-checking through community notes. While other AIs rely on old training data, Grok-5 is designed to understand the world as it happens, right now. Finally, Grok-5 is designed to be agentic. This is a fancy word that means it doesn't just talk. It acts. With a massive context window of 1.5 million tokens, Grok-5 can remember an entire library of books in a single conversation. You can feed it your entire business history or a massive code base, and it won't forget the beginning by the time it gets to the end. This allows it to reason through complex problems. It can think before it speaks. If you ask it to solve a hard math problem or write a complex software program, it can use chain of thought reasoning to plan out the steps, check its own work, and then give you the answer. It's being integrated into Tesla's Optimus robot. The idea is that Grok-5 is the brain in the cloud, and the robot is the body. The robot handles the walking and grabbing, but when it needs to figure out a complex task, like clean the kitchen, it asks Grok-5 how to do it. Grok-5 is the brain story, raw intelligence at massive scale. Now watch what happens when that kind of intelligence meets a real body. Humanoid robots are starting to move like they mean it. 2026 is the year AI robots stopped feeling like experiments. Figure 03 is now running at human jogging speed. Optimus Gen 3 feels closer than people expected. HMND-01 proved robots can work full shifts in real factories. Kepler's robot is working where humans face danger, doing real welding work. Figure just quietly raised the bar for humanoid robots, and most people almost missed it. A short video drops online, framed almost like a joke, calling it a new fitness program at Figure. At first glance, it feels playful and easy to scroll past. But if you actually watch closely, it becomes clear this is not marketing fluff. What the video really shows is Figure 03 moving with purpose. The robot transitions from a steady stride into a controlled run, accelerating forward while maintaining balance and stability. This is not a cautious demonstration designed to avoid mistakes. Figure 03 moves confidently, adjusts direction smoothly, and keeps momentum without hesitation. That moment alone challenges a long-standing belief that humanoid robots are slow, fragile, and limited to careful movements. Figure 03 reaches speeds close to a human jogging pace, around 6.5 miles per hour. That is staggering for a full-size humanoid robot. Even more impressive is how the robot handles motion changes. It accelerates quickly, slows down sharply, and executes controlled turns, all without stumbling. This shows real progress in balance, gait control, and dynamic stability, areas where humanoid robots usually fail first. Here's the key detail. This running behavior is not a scripted animation or a pre-programmed routine. Figure powers this movement using its new Helix AI system. Helix learns directly from human videos and transfers that behavior to the robot without step-by-step programming. In simple terms, Figure 03 watches how humans move and figures out how to reproduce that motion using a robotic body. This process, known as zero-shot human-to-robot transfer, is a major breakthrough. This matters because speed unlocks usefulness. A robot that can move quickly can operate in real factories, busy warehouses, and homes without slowing everything down. Figure designed Figure 03 for general-purpose work, including folding laundry, washing dishes, and assisting in commercial environments. Running shows the robot can keep up with humans instead of holding them back. The fitness program framing may sound playful, but the message is serious. Figure is training robots the way athletes train bodies, focusing on strength, balance, coordination, and recovery. When a humanoid robot can run confidently, it signals readiness for far more demanding tasks ahead. This is not a gimmick. It is a preview of robots that move with purpose, speed, and confidence. And once robots can run, the line between human pace and robot pace begins to disappear. A short AI-generated video featuring Tesla's humanoid robot, Optimus, recently went viral, and not because of flashy visuals or clever humor. The clip shows Optimus dancing alongside Elon Musk, wearing matching outfits and moving with smooth, confident body language. On the surface, it looks playful, but the reaction it triggered online revealed something more important. People began questioning whether they were looking at a believable preview of Optimus's future capabilities. The caption reads, "Feeling optimistic about the future. It feels lighthearted, almost deliberately unserious." Yet the discussion that followed told a different story. What pushed this clip into viral territory wasn't the dance itself. It was the opening frame. That first image looked real enough that viewers immediately started asking the same question. Was this an early glimpse of Optimus version 3? That question spread faster than the video. Some called it clever marketing. Others wondered if it was an accidental reveal. Either way, the clip worked because it felt believable. And believability is where perception starts to change. This moment didn't appear out of nowhere. Over the past year, Tesla has steadily released footage of Optimus walking, maintaining balance, manipulating objects, and performing coordinated movements with growing confidence. Each update quietly reset expectations. So when people see Optimus dancing, the brain doesn't reject it. It accepts it as plausible. The conversation escalated further when Simon reacted to early Optimus development with a statement that caught attention. According to Simon, Optimus 3 is advancing so rapidly that people may eventually forget Tesla ever made cars. That isn't casual hype. It reflects how the robot's trajectory looks to those closely observing its development. It reframes Optimus as a future core product rather than a side experiment. Consider the scale implied by that shift. Cars scale in millions. Humanoid robots scale in billions. One robot per household, one per worker, one per job people avoid. That is the future being suggested here. Tesla has clarified that Optimus 3 has not been publicly revealed, and current visuals still show earlier versions of the robot. But that clarification only amplifies the moment. If previous versions already feel this capable, expectations for what comes next are accelerating quickly. This is no longer just about a viral clip. It's about perception crossing a threshold. Optimus is no longer discussed like a prototype. It's being treated like an inevitable product. And once that mindset locks in, momentum follows. Instead of chasing attention with flashy demos or viral clips, Siemens made a deliberate move into humanoid robotics by testing one where it actually matters, inside a working factory. This was not a showcase or a concept reveal. It was a real-world pilot designed to answer a practical question about the future of industrial automation. Siemens partnered with a young British startup called Humanoid and deployed a robot named HMNE-01 Alpha inside the Siemens electronics factory in Erlangen. The objective was straightforward. Could a humanoid-style robot operate reliably in industrial logistics without disrupting the human workers already on the factory floor? What makes this test interesting is what Siemens did not prioritize. HMNE-01 Alpha does not move like a movie humanoid, and it does not try to mimic human walking. Instead, the robot uses a wheeled base and focuses entirely on utility. Its task was simple but demanding. Autonomously pick storage totes from stacked shelves, transport them across the factory floor, and place them onto conveyors for human workers. The system ran without remote control or human intervention, repeating the cycle until the storage stacks were empty. The real story, however, is in the performance data. During the 2-week pilot, the robot moved roughly 60 totes per hour. It operated continuously for more than 30 minutes at a time, with daily uptime exceeding 8 hours. Autonomous pick-and-place success stayed above 90%. For an early deployment, those numbers are significant. This was not a lab environment. It was a live electronics factory. Siemens described this project as a conservative first step, and that choice was intentional. HMNE-01 Alpha uses simple industrial grippers rather than human-like hands. The design feels closer to a collaborative robot than a science fiction humanoid. Siemens is clearly prioritizing reliability and consistency over realism, a strategy that could shape which companies succeed first in industrial humanoids. Physically, the robot stands about 175 centimeters tall, weighs around 70 kilograms, and handles payloads of up to 15 kilograms. Humanoid also revealed that a bipedal version of the robot learned stable walking within 48 hours using simulation-based training, offering a glimpse of what may follow. For now, Siemens demonstrated something important. Humanoid robots do not need to look human to deliver value. In industrial settings, usefulness comes from reliability, and in this pilot, the robot delivered exactly that. High-altitude welding is one of the most dangerous jobs in industrial work, and that is exactly where Shanghai Kepler's humanoid robot, K2, steps in. This robot is not doing a lab demo. This robot is operating in real conditions, at height, with real welding tools, replacing tasks that normally put human lives at risk. And here's the crazy part. It is not fully autonomous. A human operator stays safely on the ground, wearing a VR headset, and controls the K2 in real time, turning the robot into a physical avatar in dangerous environments. The Kepler K2, also known as Bumblebee, is built specifically for dirty, dull, and dangerous work. The robot has 52 degrees of freedom, which means it can copy complex human arm, wrist, and body movements with shocking accuracy. That level of motion control is critical for welding, where even small angle errors can ruin a joint. The robot uses a hybrid actuator system that combines linear and rotary actuators, giving it both strength and precision. The result is a robot that can carry up to 30 kilograms while maintaining millimeter-level accuracy. But here's the mind-blowing part. The K2 is not just strong and flexible, it is practical. The robot runs up to 8 hours on a single charge after just 1 hour of charging. That makes it suitable for full industrial shifts, not short demos. The layered VLA Plus system helps the robot interpret commands and stay stable in complex environments, while the human operator provides judgment and problem-solving during tricky welds. This approach solves 3 problems at once. Safety improves because humans are removed from high-altitude risk. Precision improves because a human brain still guides the task. And cost drops because the K2 is priced around $35,000, making advanced humanoid labor accessible to real factories. This is not a future promise. This is a working robot quietly redefining industrial labor right now. Put all these pieces together: faster AI, stronger robots, and real deployments. That's why top AI leaders are now warning the job impact could arrive faster than anyone expects.
I don't know, we might be 6 to 12 months away from when the model is doing most, maybe all of what SWEs do end to end.
In just 12 months, the job of a software engineer, the safest career in the world, could be completely vanished. That's not a clickbait headline. That is a bold, public claim made by the CEO of Anthropic, Eva.i, at the World Economic Forum in Davos just days ago. He says the age of the coder is over. AGI, artificial general intelligence, is no longer a someday technology. It's here. And if you think this is just about people sitting behind screens writing Python, think again. Humanoid robotics are no longer circus acts or dancing puppets. They are getting an AGI brain. Elon Musk is already integrating the XAI Grok brain into the Tesla Optimus. And once that connection is complete, everything changes. We aren't just automating software, we are automating reality. At the World Economic Forum, the session was literally titled "The Day After AGI." Think about that. They aren't asking if it's coming anymore. They are planning for the morning after it arrives. Eva.i, the man who helped lead OpenAI before starting Anthropic, dropped the reality check. He revealed that inside his own company, the engineers don't even write code anymore. They just edit what the AI produces.
We are now, in terms of the models that write code, I have engineers within Anthropic who say, I don't write any code anymore. I just let the model write the code, I edit it, I do the things around it. I don't know, we might be 6 to 12 months away from when the model is doing most, maybe all of what SWEs do end to end.
He predicts that within 6 to 12 months, AI will be able to do most, maybe all, of what a software engineer does end to end. Why? Because of the closing loop. 1. The AI writes code to make itself smarter. 2. The smarter AI writes even better code to improve itself again. 3. This cycle is accelerating at a rate humans can't even comprehend. Eva.i and Google DeepMind's Demis Hassabis both agreed on one thing. The bottleneck is no longer the software. The only thing slowing us down now is the physical world, and even that wall is starting to crumble. If you want proof that this isn't just tech bro hype, look at the factory floor. Right now, in South Carolina, the Figure 02 robot is working inside a BMW factory. This isn't a pilot project anymore. These robots have already moved over 90,000 parts, working 10-hour shifts with a 99% success rate. Figure recently unveiled the Figure 03, which is designed for even faster mass production. They are building a facility to churn out 12,000 of these per year. These aren't just tools. They are autonomous workers that can position metal to the millimeter using nothing but their eyes and an AGI brain. Then there's the heavyweight champion, Tesla Optimus Gen 3. Elon Musk recently confirmed that thousands of these bots are now working 24/7 across Tesla's gigafactories. They don't take lunch. They don't take sick days. And Musk says they are now being trained with end-to-end neural networks. That means they don't need a human to program them, to pick up a wrench. They just watch a video of a human doing it. and then they do it themselves. If you want to understand the future before it hits your job, hit subscribe. We don't cover hype. We track what's actually happening with AGI and humanoid robots. And don't forget Boston Dynamics. Their new electric Atlas just debuted at CES 2026. It's now being deployed at Hyundai's Meta plant in Georgia. This version can rotate its joints 360 degrees. It can do things a human body literally cannot do, all while being powered by Google's Gemini robotics models. But the real sleeper hit? China. While we focus on Tesla and Figure, Chinese companies like Unitree and AGI are mass-producing humanoids at a fraction of the cost. They've already shipped thousands of units. China is on track to produce half of the world's humanoid robots by the end of this year. We are seeing a global arms race to replace human labor with physical AI. For years, we were told computers will take the boring jobs and humans will keep the creative ones. Then we were told AI will take the white-collar office jobs, but manual labor is safe. Both of those statements are now proven false. The white-collar hit. If AI can replace a coder in 12 months, it can replace a paralegal, an accountant, or a middle manager in 6. The blue-collar hit. If a Tesla bot can work a 24/7 shift in a factory for the cost of a few kilowatt hours of electricity, the manual labor fortress has fallen too. This is the first time in history where the brain and the body of technology are evolving at the exact same time. The Anthropic CEO isn't just talking about a software update. He's talking about the restructuring of the global economy. So if the day after AGI means coding is automated, white-collar jobs are shrinking, and robots are taking over the factory floor, what is left for us? This sounds scary, but at Davos, the conversation wasn't just about doom. It was about the great adaptation. Think about the 1800s. Back then, 90% of people were farmers. When the tractor was invented, people thought it was the end of the world. But instead, it freed us up to become doctors, artists, and, ironically, software engineers. We are entering a world where the cost of labor might drop to near zero. Everything could become cheaper. Work might become something you choose to do, not something you have to do to survive. If AI can do more thinking work and robots can do more physical work, the big question becomes simple. When does this turn into a product normal people can buy?
By the end of next year, I think we'd be selling humanoid robots to the public. My prediction is that there'll be more robots than people.
According to Elon Musk, Tesla is approaching a moment few people expected this soon. By the end of next year, the company could begin selling humanoid robots to the public. You heard that right. People will actually be able to purchase Optimus and bring this robot home. But this isn't some distant promise anymore. Tesla already has Optimus robots performing real tasks inside its factories right now. These aren't prototypes sitting on a shelf collecting dust or polished demo units rolled out once a year for applause. These robots are actually working, performing meaningful, real-world tasks that matter inside real industrial environments. What Optimus is capable of right now matters less than where Tesla expects it to be by the end of this year. Speaking at the World Economic Forum annual meeting in Davos in 2026, Elon Musk made it clear that Optimus is expected to take on far more complex responsibilities inside those same factories. Not just repetitive motion, but more involved workflows that require coordination, balance, object handling, and real-time decision-making.
We do have some of the Tesla Optimus robots doing simple tasks in the factory. We expect probably later this year. By the end of this year, I think they'll be doing more complex tasks, but still deployed in an industrial environment.
This isn't theoretical progress or controlled experimentation. We're watching this technology evolve in real time, and the pace of improvement is staggering. Now here's what makes this especially interesting. Tesla hasn't announced a price yet, but Musk has said that detail will come at launch. What matters more than the price, though, is the scale of what he's describing. Elon Musk believes that everyone may have Optimus in the future, not just engineers. Not just companies, not just wealthy early adopters who buy every new piece of technology on day one. Everyone. He's talking about a future with potentially close to 1 billion humanoid robots operating on this planet. That's not a small upgrade to how we live or work. That's a complete transformation of human society as we know it. When you start thinking in numbers like that, you're no longer talking about gadgets or convenience tools. You're talking about a new economic foundation. Elon Musk says robots could outnumber humans. Does that future excite you or scare you? Drop your honest take in the comments. And this is where Musk's thinking goes deeper. He explained that economic output in a future dominated by robots depends on just two variables: the average productivity of each robot and the total number of robots deployed. When those two factors are multiplied together, they determine total economic output. It's a simple equation on the surface, but the implications are enormous. As the number of robots increases, economic output doesn't grow slowly or in a straight line. It accelerates rapidly. Musk isn't describing incremental improvement. He's describing expansion on a scale humanity has never experienced before. An economy where output is no longer constrained by human labor limits, physical fatigue, or time itself. Musk went even further, saying that artificial intelligence and robots working together could create enough abundance to fully satisfy all human needs. Not partially, not unevenly, completely. He said there may come a point where people wouldn't even be able to think of new tasks to ask robots to perform. The reason is simple. Goods and services would become so abundant that everything people require is already taken care of. Food production, housing, transportation, maintenance, care, manufacturing, handled at scale. Hit subscribe if you want real updates on humanoid robots before they reach your home. He also made one of his boldest predictions yet. Robots may eventually outnumber humans. More robots than people walking the earth. That's not science fiction framing or exaggerated speculation. What Musk is describing isn't speculation. It's what he sees as the inevitable result of humanoid robots becoming affordable, reliable, and mass-produced. And he argues that this shift could happen much sooner than people realize. So what does that mean for everyday life? Elon Musk cuts to the core. You cannot have both necessary human labor and universal abundance at the same time. If essential work still must be done by people, and only some are able or willing, then abundance stays limited and narrow. Someone is always left out. But if there are billions of humanoid robots, which Musk firmly believes there will be, abundance becomes possible for everyone. Not just people in wealthy countries, not just those with high-paying jobs or access to advanced technology. Everyone on Earth. In that scenario, access to goods and services stops being a privilege and starts becoming a baseline condition of society. Musk has consistently argued that in a world like this, humanoid robots would become something everyone wants. When you consider the scenarios he describes, the appeal becomes obvious. If these robots meet extremely high safety standards, he says people would trust them to watch over children, care for pets, and support aging parents. This ties directly into a challenge the world is already confronting. Caring for aging parents is emotionally difficult, physically demanding, and often financially overwhelming. Across many countries, populations are aging faster than younger generations can support them, creating a growing shortage of caregivers. Musk argues that a reliable humanoid robot, capable of assisting, monitoring, and protecting elderly parents, could offer a meaningful response to this emerging global crisis. Would you buy Optimus for productivity or for taking care of loved ones? Share your reason in the comments below. And he wasn't vague about it. Musk expressed confidence that such robots will exist and that they will be dependable enough to handle these responsibilities. Not experimental helpers, not fragile machines. Robots people can trust inside their homes with the people they care about most. So when will Optimus actually be ready for this kind of role? Musk has been clear that Tesla will only sell humanoid robots to the public once they reach very high reliability, very high safety, and a broad range of capabilities. That's the bar. A robot will only be released to consumers once it can be trusted to operate safely in unpredictable human environments. Musk says people would be able to ask the robot to do almost anything. Not a narrow assistant limited to pre-programmed routines, but a general-purpose humanoid robot capable of adapting to new tasks. That's an ambitious goal, but it's the standard Tesla is aiming for. Zooming out even further, Musk tied all of this to his broader view on artificial general intelligence. He made a striking prediction: AI could be smarter than any human by the end of 2026. That timeline is extremely close. Looking a few years beyond that, he predicted that by 2030 or 2031, AI could be smarter than all of humanity combined. That doesn't mean smarter than one expert or one exceptional individual. It means surpassing the combined intellectual output of every human on the planet. According to Musk, that shift would fundamentally change civilization itself. Exponential AI growth would eventually saturate human needs and unlock unprecedented global economic expansion. Musk framed his work across Tesla, SpaceX, and XAI around one central ambition: maximizing the probability that civilization has a great future. In his view, AI and robotics are not side projects or side bets. They are the core technologies that will reshape human society within the next decade. And according to him, the path to abundance for all runs directly through AI and robotics working together at massive scale. He also highlighted a less discussed bottleneck: energy. Artificial intelligence and robotics require enormous amounts of power. Without sufficient energy infrastructure, this entire vision slows down or stops altogether. Securing reliable, scalable energy is essential if AI-driven abundance is going to become reality. Are we witnessing the beginning of a golden age or the biggest disruption in history? Share your perspective in the comments below. If Musk's predictions are even partially right, this isn't the distant future. It's the near future, and we're about to watch it unfold in real time. And Tesla won't be alone in that future. China is moving fast, and XPeng just showed a humanoid that's already crossing into production. Elon Musk just got some serious competition from the East. XPeng just unveiled the ET1, a production-ready humanoid robot that's being called the Optimus killer, built on the foundation of XPeng's hyper-realistic iron robot. The ET1 is ready to work. Hey guys, Alfie here. Welcome to AI Nexus. Let's break it down. CEO He Xiaopeng confirmed it personally, standing inside the facility as the first unit rolled through. This moment matters because XPeng isn't showing a future idea anymore. This is a robot that's finished, validated, and ready to work. For years, humanoid robots have lived in demo videos and controlled showcases. Big reveals, loud applause, then silence. XPeng took a different path. The company quietly spent years building the technology, testing systems, and setting up real manufacturing infrastructure. And now that phase is over. The testing just ended. The humanoid robotics industry has been filled with bold promises. Robots that walk naturally. Robots that speak fluidly. Robots that work beside humans. What's been missing is delivery. That gap has been the industry's biggest weakness. ET1 closes it. This robot isn't a preview of what might work someday. It's a system designed to function now, outside the lab. He Xiaopeng posted about the ET1 rollout on Weibo, explaining that the robot was developed using the same standards XPeng applies to their vehicles. That's the key detail. Automotive grade means durability. It means reliability. It means the robot is built to function consistently over time, not just perform well in controlled demonstrations. The CEO spent the day with his team examining details, making sure everything met production standards. He called it a critical step toward large-scale mass production of advanced humanoid robots in 2026. Not a vision, a timeline. XPeng says mass production by 2026. Do you think humanoid robots will actually be common by then? Yes or no? Drop your answer below. So what exactly is ET1? Chinese media outlet LeaderRobot describes it as the mass production test version. That means XPeng is testing performance adjustments for real-world applications. The robot needs to work in actual commercial environments, not just on stage. ET1 represents the transition from concept to deployment. It's the production iteration of the Iron robot XPeng unveiled earlier. But here's the crazy part. Iron and ET1 aren't the same thing. Let's talk about Iron. When XPeng showed the first-generation Iron robot at their 2024 AI Day, people saw a machine with over 60 joints and 200 degrees of freedom. The robot moved smoothly. It looked striking, but Iron was a concept robot. Its purpose was to show what XPeng's technology could achieve, to signal where the company was headed, to test ideas in front of an audience. XPeng never positioned Iron as a product ready for commercial deployment. Iron was about vision and validation. Then came the second-generation Iron, unveiled at the 2025 AI Day in Guangzhou. When Iron stepped onto the stage, the reaction was instant shock. The movement felt uncannily human, almost graceful, with a distinctly feminine posture and fluid gait. Many people genuinely believed a human performer was hidden inside a costume. Underneath that realism was serious engineering. 82 degrees of freedom, a humanoid spine, bionic muscle structures, flexible full-body skin, and hands with 22 degrees of freedom powered by ultra-compact harmonic joints. 3 in-house Turing AI chips drove the system, delivering 2,250 trillion operations per second through XPeng's vision language action model. Social media erupted with claims it wasn't real. The next day, He Xiaoping cut open the robot's skin on stage, exposing the mechanical structure beneath. Iron was real, but it was never meant to deploy. It was built to challenge belief. The transition from Iron to ET1 shows evolution, not replacement. Iron demonstrated what XPeng's robotics division could build when pushing for maximum capability. ET1 takes that technology and adapts it for reliability, consistency, and mass production. Iron proved the concept. ET1 proves the execution. Think of Iron as the research vehicle and ET1 as the production model. Same core technology, different objectives. ET1 isn't a concept robot. It's a production robot. If you want to track what humanoids can actually do in the real world, hit subscribe and stay with us. ET1 focuses on practicality. The robot is built to work in commercial and public service environments. XPeng has confirmed that their humanoid robots will first deploy in positions like tour guides, shopping assistants, and customer service roles. The company already uses robots in their own operations, including factories and stores. That's not speculation. That's current deployment. ET1 is designed to scale that internal use into broader commercial applications. The robot needs to function reliably in retail, hospitality, and other service industries. It needs to handle unpredictable human interactions. It needs to work full shifts without constant maintenance. That's why automotive-grade standards matter. Let's compare what Iron and ET1 actually represent. Iron was built to showcase technological capability. ET1 is built for operational deployment. Iron needed to impress audiences with lifelike movement and advanced features. ET1 needs to complete tasks consistently in real environments. Iron could afford to be experimental. ET1 has to be dependable. Iron lived in controlled demo spaces. ET1 will work in stores, hotels, and public venues where conditions change constantly. The differences aren't about which robot is better. They're about which robot fits which purpose. If ET1 starts working as a customer service agent, what human job do you think gets replaced first? Write your prediction in the comments. Why is XPeng building humanoid robots in the first place? The company calls it their physical AI strategy. This isn't a side project. XPeng's robotics effort connects directly to their work on autonomous vehicles, robot access, and other intelligence systems. The same AI stack powers all of it. The large models, the custom chips, the sensor systems, the decision-making frameworks. XPeng is building a unified platform for embodied intelligence, whether that intelligence moves on wheels or walks on legs. The robotics division shares technology with the vehicle division. The synergy isn't theoretical, it's operational. XPeng's approach also changes the economics. Developing robots from scratch costs enormous amounts of money and time. XPeng already invested in AI infrastructure, manufacturing capacity, quality control systems, and supply chains for their vehicles. Adapting those resources for robotics reduces development costs and speeds up production timelines. The company can leverage automotive-grade testing protocols, production facilities, and distribution networks. That's why XPeng can aim for mass production by the end of 2026, while other companies are still building prototypes. So why does the ET1 rollout actually matter? Because most humanoid robot projects stop at the demo phase. Companies show impressive prototypes, then spend years trying to make them production ready. XPeng just skipped that delay. The ET1 is rolling off the line now. That means the design is finalized. The manufacturing process is established. The quality standards are defined. The robot is ready for real deployment. This shift matters because it proves humanoid robots can move from research labs into commercial production using existing industrial infrastructure. The broader impact hits several levels. First, it validates the commercial viability of humanoid robots in service roles. Second, it shows that automotive manufacturing standards can apply to robotics, potentially raising quality expectations across the industry. Third, it demonstrates that the gap between concept and production can shrink dramatically when companies leverage existing capabilities instead of building everything from scratch. And fourth, it puts pressure on competitors to deliver production units, not just prototypes. Reports emerged that Elon Musk commented on XPeng's progress, saying Tesla and Chinese companies will dominate the humanoid robot market while calling other Western companies weak. Whether that prediction holds or not, the comment highlights how seriously major players are taking this space. He Xiaoping responded by posting on X that the robot which mastered the catwalk was built by a Chinese startup. The exchange underscores the competitive dynamics shaping the industry. Elon Musk says Tesla will dominate humanoid robots after seeing ET1 roll off a real production line. Do you think XPeng could actually overtake Tesla in this race? Comment XPeng or Tesla and tell us why. ET1 isn't the final answer. It's the starting point. XPeng will learn from commercial deployment, gather operational data, identify weaknesses, and iterate on the design. The first production units will reveal gaps between lab performance and field performance. Customers will discover use cases XPeng didn't anticipate. Competitors will study the robot and develop responses. The technology will evolve rapidly once it's deployed at scale. But here's what ET1 establishes. Humanoid robots are no longer stuck in the prototype phase. They're entering the production phase. The timeline for widespread deployment just compressed. So what comes next? XPeng is targeting large-scale mass production by the end of 2026. That means thousands of units, not hundreds. The company will focus on commercial applications first, then potentially expand into household use later, though no timeline exists for consumer models. The question isn't whether humanoid robots will become common. The question is how quickly deployment accelerates once production units start shipping. And ET1 gives us the first real data point. Robots are changing the outside world, but AI is also changing what people carry every day. Now the spotlight shifts to OpenAI and a device that could redefine the AI interface. OpenAI is building a new device, and this is not a small-side experiment or a flashy concept teaser. This is a serious move into hardware, and the rumors alone are already reshaping expectations. This device is not supposed to be another phone, another watch, or another screen fighting for attention. The expectation is something pocket-sized, screenless, and deeply aware of context. An AI companion that listens, understands surroundings, and responds at the right moment instead of shouting notifications all day. This device is being positioned as a brand new category, not an upgrade to anything already in pockets. The rumors point toward a device that runs directly on OpenAI's most advanced AI models. This means ChatGPT is not just an app anymore. ChatGPT becomes the brain of a physical pocket companion. Cameras and microphones help the device understand where you are, what is happening, and when information actually matters. Instead of tapping screens, unlocking phones, and opening apps, the AI companion listens and acts naturally. This device does not replace the phone. It works with the phone. That distinction is critical because history has shown what happens when companies ignore what is already in people's pockets. The expectations are massive because OpenAI already changed the AI world once. Many believe OpenAI wants to do it again, this time with hardware. This is where Jony Ive enters the story, and this changes everything. Jony Ive is not just another designer. Jony Ive shaped modern consumer technology. Jony Ive designed the iPod, the iPhone, and the iPad while serving as Apple's chief design officer. These were not just products. These were cultural shifts. Before the iPhone, phones had buttons, keyboards, and tiny screens. After the iPhone, the entire industry reset. OpenAI bringing Jony Ive into the picture signals intent. This is not about making a gadget. This is about defining how humans interact with AI in daily life. Sam Altman, the CEO of OpenAI, and Jony Ive are working together to design a family of devices, not just one AI companion product. That phrase matters. Family of devices means a long-term vision, not a one-off experiment. Point 1 is what this OpenAI device can actually do. The core objective is to redefine what a device actually does. The Pocket Companion is expected to handle conversations, tasks, reminders, and context without demanding constant input. Instead of asking the companion every detail, the companion understands patterns over time. This is a direct response to screen fatigue. Sam Altman described current devices as overwhelming, like walking through Times Square with constant flashing lights. This new device is supposed to feel calm, like sitting in a quiet cabin away from noise. That is not marketing poetry. That is a design philosophy. This philosophy of simplicity is the driving force behind the partnership with Jony Ive. Jony Ive's design history shows obsession with simplicity, clarity, and human comfort. At Apple, Jony Ive stripped away buttons, clutter, and unnecessary elements. The same thinking applies here. Screens are not mandatory. Buttons are not mandatory. A screenless assistant that speaks and listens can be more natural than a glowing rectangle. OpenAI even acquired Ive's hardware startup to bring design and engineering under one roof. This is rare. It shows OpenAI is not outsourcing hardware vision. OpenAI wants control over how AI feels in the physical world. But here's the crazy part. They are struggling with defining the assistant's personality, privacy behavior, and infrastructure. Even giants struggle when inventing new categories. Now step back and look at the bigger picture. Smartphones and laptops were the biggest revolutions of modern personal technology. They changed communication, work, and entertainment. But now these devices are mature. Phones today are faster, better cameras, and brighter displays. But the change year to year is small. 5% better camera, slightly thinner body, a bit more battery life. That is not a revolution. From the early 2000s to now, phones absorbed cameras, music players, GPS, and keyboards. That transformation already happened. Today's updates are refinements, not breakthroughs. This maturity signals something important. The next big leap will not come from another glass slab. Every major company understands this. That is why the new bet is AI hardware. Whoever defines the next dominant form factor wins. Whoever arrives first and gets adoption wins big. ChatGPT became the top AI platform largely because it arrived early and scaled fast. The same logic applies here. If OpenAI defines how people physically interact with AI first, OpenAI sets the standard. Everyone else follows. This is why this device matters so much. This is not about selling units. This is about controlling the future interface of intelligence. Now look around the industry, and you can see the race unfolding. Meta is building Project Orion. These are advanced AR glasses with holographic displays, cameras, and AI integration. The vision is bold: glasses that replace phones, digital content floating in the real world. But the technology is still expensive and bulky. The prototypes cost thousands of dollars. Meta knows this is not ready for mass adoption yet, but Meta is betting that glasses are the next computing platform. Ray-Ban Meta glasses already test the idea without displays, voice, camera, and AI as a helper. Project Orion pushes that idea further with visuals. Then there are other experiments, like the Friend Pendant, a necklace device that listens constantly and offers companionship. The idea sounds emotional and futuristic, a device that comments on life and keeps company. But public reaction has been mixed at best. Many people feel uncomfortable with always listening devices. Others question whether companionship devices solve real problems or create new ones. This brings us to usefulness, the core question. What does this OpenAI AI companion actually help with? The promise is friction removal. No more unlocking phones. No more switching apps. No more typing simple commands. The AI companion listens, understands, and acts. It can trigger actions on connected devices. It can summarize information when attention is available. It can stay silent when focus matters. Over time, the AI companion becomes more helpful because it learns context. This is not about replacing humans. This is about reducing cognitive load. Small wins add up. Less distraction, less screen time, more flow. But here's the crazy part. This only works if the AI companion integrates with existing devices instead of competing with them. History already showed what happens when companies ignore this rule. The humane AI pin tried to replace the phone. It failed hard. The AI companion clipped onto clothing, projected visuals onto the hand, and promised a screenless future. In reality, it overheated, drained battery, and felt awkward. It demanded a monthly subscription and refused to work alongside phones. Consumers rejected it. The lesson was brutal. Phones are too powerful and too central to daily life to be replaced easily. Rabbit-R1 followed a similar path, a pocket-sized device with voice-first control and a quirky design. It promised to handle tasks across apps using AI. The idea was exciting. The execution was not ready. Slow performance, bugs, and limited reliability made the device feel like extra friction instead of less. It became a novelty instead of a necessity. These failures are not because AI hardware is doomed. They failed because they ignored real-world behavior. People want helpers, not replacements. This is where OpenAI's approach looks different. OpenAI does not position this device as a phone killer. OpenAI positions it as a companion, a silent assistant, a layer above existing tools. That distinction could decide everything. It earns trust over time. It connects to phones, laptops, and services instead of isolating itself. That is a smarter strategy. And while the next interface is being built, today's humanoids are still training in the real world. And sometimes that training turns into a viral moment. Unitree's humanoid robot just went viral for all the wrong reasons. What started as a normal training session inside a robotics lab turned into one of the most hilarious accidents the internet has seen. The Unitree G1 is one of China's most advanced humanoid robots, built to copy human motion with near-perfect precision. But during one training session, that precision turned into pain. Inside a robotics lab, an engineer suited up in a motion capture system to teach the G1 new movements. The setup was simple. Every time he moved, the robot would do the same in real time. The goal was to help the G1 learn complex balance and coordination, the kind needed for martial arts style stances and quick reflexes. But one small mistake changed everything. As the session started, the engineer lifted his leg to demonstrate a front kick. The G1 mirrored the move exactly. The problem? Both were facing the same direction, not opposite each other. So when the man kicked forward, his own foot swung straight up and struck him right in the groin. He collapsed instantly. And here's where it got hilarious. The G1, doing what it was programmed to do, copied his reaction perfectly. It bent forward in the same motion, as if sharing the pain. The whole lab burst into laughter. And within hours, the video hit social media and exploded worldwide. But beneath the comedy is a reminder of how advanced Unitree's robots have become. The G1 has already stunned the internet with its kung fu-style demos, spinning kicks, flips, and lightning-fast moves that prove just how fluid its mechanics really are. It's not a joke robot. It's a serious piece of technology priced at around $16,000, used for AI training and education. Still, this incident shows something deeper. When a robot mirrors us too well, even a simple kick can turn into a perfect storm of precision, timing, and pure comedy. AI companions are getting warmer, more lifelike, and more personal. But the next leap is even bigger, connecting the human brain directly to machines, and Neuralink is already doing it. For years, Neuralink sounded like science fiction. A brain implant that lets you control technology using only your thoughts felt like something decades away. But today, that future is no longer theoretical. It is happening right now, inside real human brains. In just 2 years, Neuralink has moved from its first human implant to 21 active patients, all using a brain-computer interface in daily life. These are not short demos or controlled lab experiments. These are people using Neuralink at home, for school, for work, and for basic independence. What makes this moment important is not just the medical progress. It is what this technology represents for the future of AI, robotics, and human-machine control. Neuralink is quietly building the missing link between the human brain and intelligent machines. At its core, Neuralink solved a very specific problem. When someone becomes paralyzed, the brain usually still knows how to move. The signals are still generated, but they never reach the muscles because the neural pathways are damaged. Neuralink bypasses that broken pathway. Instead of sending signals from the brain to the body, Neuralink captures those signals directly from the brain and translates them into digital commands. These commands can control a computer, a phone, or even a robotic device. Their first product, called telepathy, allows users to control a cursor simply by thinking about movement. At first, patients imagine moving their hand to guide the cursor. But something interesting happens very quickly. The brain adapts. Within minutes, many users stop thinking about their hand entirely. The cursor begins to feel like a natural extension of their mind. Some patients have even reported that the cursor reaches the target before they consciously realize where they wanted it to go. This is where Neuralink stops being a medical tool and starts becoming an AI interface. Neuralink is currently focused on clinical trials, not consumer products. The goal right now is learning, iteration, and safety. With 21 patients enrolled, Neuralink is collecting massive amounts of neural data. Every brain is different. Signal strength varies based on anatomy, injury type, disease progression, and even subtle brain movement. Neuralink uses AI models to adapt in real time, filtering noise and improving accuracy for each individual user. This is not a static system. The implant learns with the user. Some participants now use telepathy for more than 15 hours a day. They study, browse the internet, write, create, and communicate entirely through thought-based control. That level of daily usage proves something important. This is no longer experimental interaction. It is becoming a usable interface. The Neuralink implant is a small device placed directly into the brain. It uses extremely thin electrode threads that are inserted into regions responsible for hand and arm movement. These threads read neural activity at a very high resolution. The implant does not stimulate the brain. It listens. The signals it captures are sent wirelessly to a computer, where AI models decode the user's intent and translate it into actions. Over time, both the AI system and the human brain adapt to each other, creating smoother and faster control. In terms of speed, some Neuralink users have already reached information transfer rates comparable to able-bodied people using a mouse. That means thought-based control is approaching the speed of physical movement. This matters deeply for robotics. Robots do not need muscle signals. They need intent. Neuralink is proving that intent can be extracted directly from the brain in real time. One of the most overlooked but critical parts of Neuralink is the surgical robot. Implanting thousands of microscopic threads into the brain requires precision that human hands cannot achieve reliably. Neuralink built a custom surgical robot to perform the procedure. This robot uses advanced imaging and computer vision to avoid blood vessels and place each thread with extreme accuracy. It adjusts in real time to brain movement caused by breathing or heartbeat. This is robotics enabling neuroscience. Without this robot, Neuralink would not scale. Every improvement to the surgical system increases safety, consistency, and signal quality. This is the same principle we see across advanced robotics. Automation enables precision at a level humans alone cannot maintain. The real impact of Neuralink becomes clear when you look at individual patients. Noland, the first Neuralink recipient, had been paralyzed for over 10 years. Before Neuralink, he relied on others for nearly everything. With telepathy, he regained full control of a computer. He returned to college, studies mathematics, reads extensively, and is now pursuing a degree in neuroscience. Another patient, Nick, had not moved his limbs in 4 years. Using Neuralink, he controlled a robotic arm to perform physical tasks like feeding himself and scratching an itch. What surprised him most was not the control itself, but the sensation. His brain felt like it was moving his arm again, even though the movement happened through a robot. Sebastian, a medical student, increased his productivity dramatically after receiving Neuralink. Voice commands once slowed him down. Thought-based control removed that friction entirely. Audrey, who had not directly used a computer for nearly 2 decades, began creating digital art using Neuralink. For her, the implant restored a sense of ownership and creative freedom that had been gone for years. These are not just success stories. They are early examples of what happens when the brain gains a direct interface with machines. Now zoom out. If a human brain can control a cursor, a robotic arm, and a camera, the next step is obvious. Humanoid robots, industrial robots, and autonomous machines could one day be guided directly by human intent. Imagine a future where a person thinks about performing a task and a robot executes it instantly. No controller, no programming, no delay. This does not replace AI. It complements it. AI handles perception, balance, and execution. Humans provide intent, judgment, and creativity. Neuralink becomes the bridge. This is how humans stay in the loop as robots grow more capable. Elon Musk has been clear about one concern for years. Artificial intelligence is improving faster than humans are evolving. If humans remain limited by slow interfaces like keyboards, touchscreens, and voice commands, they risk becoming spectators in an AI-driven world. Neuralink is not about fighting AI. It is about upgrading the human interface. By increasing the bandwidth between the brain and machines, humans gain new abilities instead of losing relevance. Thought-based communication, robotic control, and direct digital interaction allowed humans to operate at the speed of intelligent systems. This is not about becoming superhuman. It is about staying competitive in a world filled with advanced AI and robotics. Looking forward, Neuralink has clear goals. They plan to increase the number of electrodes from around 1,000 to over 3,000 to capture richer neural data. They are improving thread retention to maintain signal quality over time. They are refining surgical techniques to reduce invasiveness and speed up recovery. Neuralink is also expanding into communication. New trials aim to restore real-time speech for people with severe speech impairment by decoding signals from speech-related brain regions. Long-term, the vision goes far beyond medical use. Brain-computer interfaces could become a standard way humans interact with robots, AI systems, and digital environments. What we are seeing now is not the final product. It is the first working version of a new interface. Neuralink is the brain-to-machine link. Now zoom out to the biggest tech stage, CES 2026, where robots and gadgets prove this shift is going mainstream. Forget everything you knew. CES 2026 just proved the robot revolution is officially here. Realbotics unveiled a humanoid so lifelike, it actually solves the uncanny valley. Engine AI's T800 proved that robots can now jump and sprint like pro athletes. Tombot introduced Jenny, the robotic pup designed for pure emotional comfort. From rollable laptops to AI-powered sneaker cleaners and L'Oreal AI face masks, it was a wild show. Hey guys, Alfie here. Welcome to the AI Nexus. Let's get into it. Robotics introduced Eva.i, a male humanoid designed to push realism far beyond previous demos. Eva.i uses advanced facial animation systems that sync speech with micro-expressions. When the robot smiles, muscles around the eyes react naturally. When it pauses, the face settles instead of freezing. This solves one of robotics' biggest problems, the uncanny valley. Built on the Ask Aria platform, the system adjusts tone and expression based on detected emotion. It is positioned for entertainment, hospitality, and customer-facing roles. The result feels less like a machine responding and more like a presence reacting in real time. If realism was one extreme, raw physical ability was the other. Engine AI showcased two humanoids that focus entirely on motion and strength. The PM01 is a lightweight embodied agent designed for real-world environments like malls, stations, and guided tours. Movement is smooth, controlled, and practical. Then comes the T800. This full-scale humanoid delivers up to 450 Nm of torque per joint and 14,000 watts of instantaneous power. That level of force allows sprinting, jumping, and combat-style movement. Instead of slow mechanical steps, the T800 moves like a trained athlete. This shift marks a move away from staged concepts and toward robots built for factories, emergency response, and physical labor. Not every robot at CES was built for power or speed. Some were designed for comfort. Tombot presented Jenny, a robotic companion created for seniors with dementia and individuals dealing with anxiety. Jenny uses 9 servo motors to control subtle movements: ears, head tilt, eyebrows, and tail. The design was developed with Jim Henson's Creature Shop, giving it lifelike motion instead of rigid animation. Capacitive touch sensors allow the robot to respond when petted or held. When interaction stops, Jenny reacts with gentle movement to re-engage. Priced around $1,500, it replaces neither therapy nor care, but offers emotional presence for people unable to maintain a real pet. Displays took a major leap forward with Lenovo's ThinkPad Rollable XD. At first glance, it looks like a standard 13.3-inch laptop. Then the screen expands upward into a full 16-inch vertical workspace. The rollable panel is powered by dual motors and steel cable support to keep the display flat and rigid. Unlike earlier concepts, there's no warping or distortion. Part of the screen wraps around the exterior when closed, enabling a world-facing display for notifications or schedules. This design removes the need for external monitors while keeping the device travel-friendly. It's a practical evolution of foldables, focused on productivity rather than spectacle. CES always delivers unexpected products. One of the most talked about was the Brolon Clear X, an AI-powered shoe cleaning system. Shoes are scanned internally to identify material types like leather, suede, or mesh. Based on that data, the system selects a cleaning and drying cycle automatically. The core technology uses micro-nanobubbles, which penetrate fabric without soaking it. This removes dirt while preserving structure and glue. With an estimated price between $500 and $800, it targets collectors rather than casual users. For sneaker preservation, it may solve a problem most didn't know could be automated. Behind many of these machines is one key player, Qualcomm. At CES, the company unveiled the Dragon Wing IQ-10 chip, built specifically for physical AI systems. The chip features an 18-core Orion CPU and delivers 700 TOPS of AI performance. That's more than 10 times the power of most AI laptops. It supports up to 20 simultaneous camera inputs, allowing robots to see, reason, and act in real time. Qualcomm pairs this with a visual language action model, meaning robots understand what objects are and how they should be handled. This architecture is designed to move robotics out of labs and into everyday environments. Personal flight returned in a serious way with the Air EV. Unlike air taxi concepts, this electric vertical takeoff and landing is designed for private ownership. The aircraft uses a fly-by-wire system where onboard computers manage stability while the pilot controls direction. It reaches speeds of 155 miles per hour with a range of 110 miles. For the 2026 version, blade geometry was redesigned to reduce noise, one of the biggest barriers to personal aircraft adoption. Instead of futuristic visuals, Air 1 focuses on usability and garage-scale storage. It positions personal flight as a lifestyle tool, not a science experiment. If Air 1 is a flying car, the Rictor X4 is closer to a flying dirt bike, built for solo pilots. It uses a multi-rotor design with an open field of view. The standout feature is autonomous obstacle avoidance. Using LiDAR and ultrasonic sensors, the system detects trees, cables, and terrain in real time. Takeoff and landing are fully AI-assisted, lowering the barrier for new pilots. Battery density improvements pushed flight time to 30 minutes, a notable jump from earlier versions. The X4 represents a shift from proving flight is possible to proving it can be safe and accessible. Minimalism took an extreme form with the HP EliteBoard G1A. There is no separate PC. The keyboard is the computer. Inside its 0.7-inch chassis sits an AMD Ryzen AI 300 series processor, cooling system, speakers, and microphones. It qualifies as a Copilot Plus PC with a dedicated NPU for AI workloads. Weighing under 1.5 pounds, it connects to any display via USB-C. The internal design is modular, allowing RAM and storage upgrades. This concept brings back the spirit of early home computers, updated for cloud workflows and AI-driven productivity. Wearables also received a major AI upgrade. Lenovo previewed Kyra, lightweight AI-powered glasses weighing just 45 grams. The system delivers near-instant live translation and contextual summaries of missed notifications, all without heavy hardware. For younger users, the Luca AI Cube targets Gen Alpha. The Cube uses multimodal AI to identify objects and explain them through stories and facts. Instead of screen-based interaction, it encourages real-world exploration. These devices show AI moving away from apps and toward ambient, everyday assistance. Beauty technology took a scientific turn with L'Oreal's LED face mask prototype. The flexible silicone mask uses 630 nanometers red light and 830 nanometers near-infrared light, wavelengths known to support collagen production and skin repair. An integrated microcircuit controls exposure time and intensity to prevent overuse. Unlike rigid masks, this design conforms to facial contours for even treatment. Set for a 2027 launch, it represents skincare moving into regulated, data-driven wellness rather than cosmetic experimentation. Displays reached another milestone with the Samsung Z Tri-Fold. Fully unfolded, it becomes a 10-inch tablet-sized screen. Despite the size, the device is just 12.9 millimeters thick when folded. A dual-hinge system allows 3 apps to run side-by-side with no performance drop. Powered by the Snapdragon 8 Elite and paired with a 200MP camera, the device focuses on productivity rather than novelty. This design shows foldables maturing into serious computing tools instead of experimental form factors. The show closed on a softer note with Echevac's Lil Milo, an emotional companion robot. Designed like a small animatronic dog, Lil Milo uses facial recognition and voice detection to interact naturally. Its charging station is shaped like a dog bed. When battery runs low, the robot crawls in and sleeps while charging wirelessly. This design avoids mechanical reminders of power and maintenance. Lil Milo highlights a growing trend at CES. Robots not just as tools, but as quiet, emotional fixtures in everyday spaces. The floor is filled with big announcements, robots around every corner, and AI woven into nearly every booth. Boston Dynamics unveiled the new Atlas at CES 2026, and for the first time. This version of Atlas is built for work, not stunts. There were no backflips on stage. Instead, Boston Dynamics introduced a production-ready humanoid designed for reliable, everyday tasks in real environments. The new Atlas is part of Hyundai Motor Group's long-term AI and robotics strategy, with early deployments planned inside Hyundai manufacturing facilities. The robot is fully sealed, water-resistant, and built to survive factory conditions, operating across a wide temperature range from cold storage areas to hot industrial floors. Atlas uses a swappable battery system that allows up to 4 hours of continuous operation, and when power runs low, the robot can navigate to a station and replace its own battery, reducing downtime and human supervision. A major shift with Atlas is intelligence. Through a new partnership with Google DeepMind, Boston Dynamics is integrating advanced AI models, built on Google's Gemini robotics work, directly into Atlas, bringing advanced perception, decision-making, and learning into the robot. LG took the CES 2026 stage to introduce Celoid, the robot at the center of LG's zero-labor home vision. LG calls Celoid a home-specialized AI agent, designed to physically take over daily chores inside real homes. Celoid has a humanoid-inspired design, with a screen that shows expressions, a torso that can stretch and tilt, and 2 highly dexterous arms, but no legs. Instead, LG chose a wheeled base with a very low center of gravity. That makes Celoid faster, safer, and far more stable than walking robots. What truly sets Celoid apart is intelligence. LG uses a combination of vision language models and vision language action models, enabling Celoid to understand what it sees and turn instructions into real physical actions. On stage, Celoid loaded laundry, folded towels, cleared obstacles for a robot vacuum, and prepared breakfast using connected LG appliances. This wasn't AI talking, it was AI working. Samsung delivered one of the biggest display moments at CES 2026 with its 130-inch micro RGB TV, our 95H, which won a Best of Innovation award. Standing in front of it doesn't feel like watching a screen. It feels like looking through a window. This is Samsung's most advanced consumer display to date. Unlike traditional TVs that use white LEDs and color filters, micro RGB uses ultra-small red, green, and blue diodes that emit pure light directly. Each color is controlled independently, allowing far higher brightness, deeper contrast, and color accuracy that conventional panels simply can't match. Powering this is Samsung's new Micro RGB AI Engine Pro, which dynamically adjusts color and light at the pixel level in real time. Samsung paired the panel with a timeless frame design, making the display look more like a floating architectural window than a television. With the R95H, Samsung isn't just improving picture quality, it's redefining what a large format display can feel like inside a living space. This one caught everyone off guard. LEGO unveiled smart bricks. Every brick has a tiny ASIC chip inside and copper coils. They use something called BrickNet, a wireless layer that lets the bricks talk to each other. If you build a spaceship, the bricks know it's a spaceship and play engine sounds from a tiny built-in speaker. If you change it into a house, the sounds change. It's basically turning physical toys into a living video game. It's a massive jump from the simple power functions we've had for years. Robotic revealed the Ceros rover at CES 2026, and what makes it important isn't raw power, it's mobility. For years, robot vacuums have failed at one simple thing: moving through real homes. Rugs, door thresholds, uneven floors, and small obstacles have always been the point where these robots stop and give up. Ceros changes that by rethinking how a robot vacuum moves. Instead of relying only on small wheels, it uses a hybrid leg and wheel system that allows the body to lift, adjust, and climb over obstacles that traditional designs simply can't handle. This lets Ceros move between rooms, across raised surfaces, and into spaces that were previously off-limits to robot cleaners. For the gamers, the Asus ROG Zephyrus Duo got a massive refresh. It's now running on the new Intel Core Ultra Series 3. We'll get to that later. The dual-screen setup is now seamless, with a new hinge that makes it look like one giant curved display when open. It's the first laptop that feels like a true desktop replacement without weighing 20 pounds. Mercedes showed off the new CLA, but the car wasn't the headline. The brain was. It's the first car to run NVIDIA's Alpamayo system. This car doesn't just follow lanes, it reasons. If it sees a ball bounce into the street, it knows a kid might follow it. That causal reasoning is the holy grail of self-driving, and Mercedes is putting it on the road this year. SwitchBot made one of the most surprising jumps at CES 2026. SwitchBot unveiled Onero H1, its first general-purpose humanoid robot and the centerpiece of Smart Home 2.0. Onero H1 isn't a vacuum or a single-task robot. It's designed as a mobile helper for everyday home tasks. What sets H1 apart is its upper body. With highly articulated arms, the robot can reach, grasp, and manipulate objects in a way that feels closer to a human assistant than a gadget. The key shift is intelligence. Onero H1 uses on-device vision and reasoning, meaning it understands objects, space, and actions without relying on the cloud. Zreal brought their latest AR glasses. They finally solved the bulk problem. These look like regular thick-rimmed glasses, but can project a 200-inch virtual screen. The big update this year is the field of view. It's 30% wider than last year, so the edges of your virtual monitor don't disappear when you move your head. And for the weird but cool find, the Glide Smart Hair Clipper. It uses AI sensors to detect the density of your hair and adjust the motor speed in real time, so it never pulls. It even maps your head and tells you if you've missed a spot on the back. It's a bit over-engineered, sure, but after seeing it, you'll never want a dumb clipper again. At CES 2026, 3 companies made it clear that the smart home is no longer about gadgets. It's about AI that lives with you, and each company is approaching that future very differently. Samsung framed its entire strategy around your companion to AI living. Samsung's idea of home AI is an invisible system that quietly manages daily life in the background. Inside its bespoke AI ecosystem, appliances share context with each other. The fridge doesn't just recognize food, it understands expiration timelines and suggests meals to reduce waste. If laundry finishes, the TV can notify you. The goal isn't personality or emotion, it's coordination. Samsung wants the home to feel like a perfectly synchronized control system that anticipates needs before you ask. LG is taking a very different route with what it calls affectionate intelligence. LG's vision focuses on emotional awareness rather than pure efficiency. Its AI systems are designed to respond to mood, routine, and presence. Lighting, sound, and environment adapt automatically, while CLOID acts as a physical companion that can assist when needed. LG isn't trying to optimize your schedule. It's trying to make the home feel supportive, calm, and human. Then there's SwitchBot, which is positioning itself as the most accessible entry into this future. With Smart Home 2.0 and the Nico AI Pet, SwitchBot brings embodied AI into homes at a smaller, more affordable scale. It's not about perfection, it's about practicality. Together, these 3 visions show where home AI is heading. Not just smarter homes, but homes that understand how you live. Everything we've talked about so far, robots, smart homes, cars, massive displays, only exist because of 3 companies. This is the brain of CES 2026. NVIDIA opened the show with a clear message. AI is no longer just software. It's becoming physical. Jensen Huang confirmed that the new Vera Rubin architecture is now in production, setting the foundation for the next wave of AI systems. But the real shift came with Alpamayo, an OpenAI platform designed specifically for autonomous driving. NVIDIA isn't just building chips for cars, it's building intelligence that any automaker can plug into. For gamers, there was no new flagship GPU. But DLSS 4.5 quietly stole attention by using advanced frame generation to dramatically smooth gameplay without needing new hardware. And then there's Project GR00T, NVIDIA's humanoid robot intelligence stack. Robots can now learn tasks by watching a human once, instead of being programmed line by line. This is the closest thing yet to a ChatGPT moment for physical robots. AMD followed with one of its strongest CES keynotes ever. Lisa Su positioned AMD as a company operating across laptops, data centers, and even space. New Ryzen AI chips push powerful AI processing directly onto personal devices, making fully offline AI assistants practical. The biggest moment came when Greg Brockman joined her on stage to announce a massive infrastructure partnership, with OpenAI planning to deploy gigawatts of AMD power compute. AMD also revealed its chips are now flying aboard Blue Origin lunar missions, while new Helios data center systems target NVIDIA head-on. Then there's Intel, quietly staging a comeback. Intel unveiled Core Ultra Series 3, built on its advanced 18A manufacturing process, bringing serious AI performance to everyday PCs. New Battlemage graphics aim squarely at the mid-range GPU market. But the surprise was Eva.i, a humanoid robot running entirely on Intel Edge processors. Intel isn't just powering screens and spreadsheets. It's putting AI into motion. All right, let's talk about AI wearables. Xiaomi showed one of the most interesting AI wearables at CES 2026 with its open mind interface. Unlike earlier AI pendants that felt invasive or cloud-dependent, Xiaomi is designed to act as a private, on-device AI coach that understands context, not just voice commands. The key shift is where the intelligence lives. Xiaomi runs on-device small language models, meaning conversations are processed directly on the wearable instead of being sent to remote servers. This improves privacy and cuts response time to near zero. In real use, Xiaomi doesn't just record meetings. It understands them, tags important moments, and recalls details instantly when asked. It's subtle, fast, and genuinely useful, turning AI memory into something you'd actually wear. Next, let's talk about your eyes. TCL's Rainio division turned heads at CES 2026 with the Rainio Air 4 Pro AR glasses. Unlike earlier AR glasses that felt good only for casual viewing, the Air 4 Pro is the world's first HDR10 enabled AR display, delivering brighter highlights and richer colors that finally feel premium. Dual micro-OLED screens push high brightness while staying ultra-light, making long viewing sessions comfortable. Rainio also solved one of AR's biggest pain points with built-in vision adjustment dials, eliminating the need for custom prescription lenses. At a fraction of the weight and rumored cost of high-end headsets, the Air 4 Pro makes personal AR displays feel practical, wearable, and ready for everyday use. Okay, this next one is genuinely adorable. Takway unveiled Svikar at CES 2026, an AI-powered pocket pet that feels like a modern take on Tamagotchis, only far smarter. Unlike last year's AI companions that lived on phone screens, Svikar is a physical, egg-shaped device with a face, haptic ears, and a personality that actually grows. It starts as an egg, evolves through interaction, and slowly adapts to how you talk and behave. Over time, it develops its own character and even goes on virtual adventures, sharing stories and creations with you. It's not just an AI toy. It feels like a tiny, evolving companion you carry in your pocket. Bird-Fi raised the bar at CES 2026 with two standout reveals: the Bird-Fi Feeder Vista and Humbloom. The Vista rethinks smart feeders with a 360-degree camera system, giving a full panoramic view instead of a single fixed angle. A clever bottom-up feeding design keeps seeds out of the way, so the camera never misses a moment. For hummingbird fans, Humbloom captures ultra-slow motion footage, revealing wing movement the human eye can't see. Paired with upgraded AI that explains bird behavior, Bird-Fi turns backyard watching into a living nature documentary. If you hate cooking, This one matters. Nosh introduced a countertop robot chef at CES 2026 that's finally built for everyday kitchens. Unlike past cooking robots that felt industrial and unreachable, Nosh actually cooks meals from raw ingredients. You load the food, pick a recipe, and the robot handles stirring, heat control, and timing automatically. With hundreds of dishes supported and even a live camera to monitor cooking remotely, Nosh feels like a real step beyond smart appliances and closer to automated home cooking. We can't talk about CES without talking about cars. Sony Honda Mobility showed the Afeela pre-production model at CES 2026, and it feels less like a car and more like a rolling entertainment and AI platform. The front, media bar, display, and deep PlayStation integration turned charging time into gaming time. Underneath, Afeela runs on Qualcomm's AI-driven digital chassis, using advanced sensors and vision language models to understand road situations before they fully unfold. It's not just transportation. It's a mobile AI agent aimed squarely at premium electric cars. The biggest moment at CES 2026 came when Uber revealed its return to hardware, partnering with Lucid and Neuro. The result is a fully driverless luxury robotaxi with no steering wheel, built for real city use. Powered by NVIDIA's automotive AI platform, it combines autonomy, comfort, and scale. With pilot launches planned for late 2026, this finally makes the driverless dream feel real, not theoretical.